Right, we're just going to wait for one or two more people to come sit down, and then we'll get started. We've got a couple live viewers online. We've got a hybrid event today. Awesome. Right then, so hello everybody, and welcome to the London Microsoft Reactor Meetup. This is the first one that we're hosting, and I am your host. My name is Liam Hampton. I'm a Microsoft Cloud Advocate here in London, and yeah, we're starting today with Web3. So hello to everybody online as well. Yep, if anything happens, fire exit is at the back and on the side. The toilets are at the back, just where you came in as well. The questions for this will be done online first, because we want to give sort of them a chance to come and speak to everybody as well. So the speakers will be taking those ones, and then we'll do a couple of in-person questions as well. So without further ado, I'm actually going to bring up Sandeep, our first speaker, because we want to get snappy going with this pretty snappy.
Cheers, Liam. Cool, thank you. First of all, thanks for taking the time and coming down to listen to the event. I know you could have probably sat at home and connected if you wanted as well, just like some of the people connected home as well. In terms of me, I'm Sandeep Krishnappa. I'm a Chief Product Officer of a company called Climatelink, and my focus is around building a community for people focused on climate change in the Web3 world. So that's where my interest is. In terms of today's topic, I'm going to talk about blockchain and Web3. It's a nice introductory session because I think we've got some deep dive sessions later where you can get a bit more, in-depth understanding of some of the concepts of Web3. I'm not an expert when it comes to blockchain, but I've spent, I think, probably 6 to 7 years looking into blockchain, helping people understand how blockchain works. And because I've been working in multiple industries, starting from finance, then moving into fast-moving consumer goods, then into energy, government solutions, background verification, and right now in climate change, I kind of feel I can explain what blockchain is so that it helps people understand without having the technical knowledge of what blockchain is. And I think once you get some basic understanding on what blockchain can do for people, you'll start understanding where the Web3 actually came into form. Because I think people have been talking about blockchain for a while now, but Web3 is something you've been hearing more since the last 12 to 13 months. So I think that bridge I can bring together once I explain a bit about blockchain. So I don't have too many slides on blockchain because, again, there's so many different elements in blockchain which can go as a complete rabbit hole, and that can take probably a whole day. If you're ready to listen, then I can speak, but obviously we don't have time today for it. So I'm going to just slightly touch most of the concepts of blockchain. So before I go into blockchain, I think this is a nice way to show how blockchain works. But one of the fundamental questions I always get asked by people is, why do you want to use blockchain? Why can't we just use a normal database? That's like a common question I get from people all the time. And every time I start telling people something like, blockchain is great because you'll have a central place which is accessible for everyone. It's transparent, and anyone can actually see what the data is. People always say you can do that with a normal database as well. I think the problem with having something central in one database is it becomes like a honeypot where everybody would want to come and look at what's in it, that they want to probably try to break it. And this is where I think blockchain starts playing an interesting role because it's distributed. It's not there in one place. It's there in every single location, depending on who's running this blockchain. So let's take an example of the number of people sitting here. And if each of you decide that you want to have a copy of your own database, blockchain works like a, a simple seed where you can put seeds in different places. And every time something gets stored, it gets stored in every single location which you're holding on to. So let's say, for example, somebody wants to buy a product. So you went to Tesco, you bought a sandwich, and you paid, say, £2 for the sandwich. In the blockchain world, I'll quickly explain how that works as a transaction. So you probably made a payment. That payment details get sent to every single node. So in this case, if each one of you are running a blockchain node as a seed, you get access to it. You get to see it. And then you decide to validate saying, yes, it's a payment which is made for, say, a Tesco sandwich. And that gets into a central node. And what happens is a lot of people are buying sandwiches. Probably some are buying in Marks and Spencer's, or some are buying in their local store. So all those transactions gets bundled together into one small block, and that block gets added into a chain. Because typically when you look at databases, you just put a data in a storage. But in blockchain, what happens is the data is actually stored like a chain format. So every time a new block comes where you have multiple people's transaction, that will end up adding into the chain. And what happens is this way, if somebody tries to tamper one of the blocks, the block knows that somebody's done a change because it's clever enough to see if somebody's trying to tamper it. And that's where I think it gets really interesting in blockchain. From a technical aspect, it sounds very simple, but it's pretty complicated because they tend to bring multiple disciplines together, like cryptography. They start looking at the mathematical way of certain problems being solved. So for most of the people who tend to use blockchain, they don't need to know all this, because this is where, just like how when we try to use the internet to send emails, you don't have to know how things happen. That's the stage where blockchain can start moving towards the use cases. And this is where I think it starts adding more value for people. And I think some of the common, plus points of putting data on a blockchain is what is listed there, which is on transparency, making sure that people can't fudge the data. At the same time, it's also about making things censor-proof. So those are some of the really interesting use cases where blockchain can add value. But if you are from a specific industry, say you're from finance, or you're from energy, or you're from government services, you've got different specific use cases. And I think this is where the value really comes. When you take something really interesting like blockchain and you bring it to a specific industry, that's where people start seeing the value, which is why rather than trying to explain to people what actually blockchain does, it's much more easier to tell people with a specific use case, depending on which industry they're coming from, so that they can relate to it. This is why when I first heard that I can talk about blockchain as a basic, when I heard that I'm going to also be talking about Web3, it was great, because now I can actually bring this whole thing to life from a Web3 concept standpoint, because then it starts making sense more. So without spending too much time on this, let me jump straight into Web3, because that's where most of these concepts will start coming to life. The whole concept about how you can create tokens, for example. On blockchain, you can create your own tokens, and this tokens forms some kind of an incentive depending on what use cases you are looking at. Blockchain also gives you an opportunity to write code, just like most of the codes which you write, but the predominant reason why people would write codes is how to use these tokens. Is it to give someone or to receive someone? It's all around the incentive side. And this is where I think it gets more and more interesting when it comes to the world of blockchain. And again, I'm sure most of you have already heard a lot about NFTs. NFTs is just one of the type of tokens which blockchain gives. There are two key types of tokens. One is a normal token, which is fungible token, which you can think of it as the money which is in your pocket, which is the same. And the second type of token is the NFT. And I'm sure there is going to be more conversation about NFT because we have a deep dive session just on NFT. So I won't try to explain that. I'm going to let the speaker speak about NFTs. But what I've found really interesting in the last 6 years when it comes to the blockchain space is the kind of debate which happens in blockchain, especially around should we have a private blockchain or a public blockchain. And for those who are not sure what these two are, public blockchain is which runs in public domain. You and I can connect to a computer and download this and you can run it. Private is something which only maybe 5 companies together would decide to run it, and that becomes a private. So there's a bit of a debate in terms of should we use a private blockchain versus public blockchain. And the reason why I thought I should mention this is because I started my journey in blockchain in the finance industry, there was a lot of talk about using private blockchains because people didn't want to put stuff in the public space. So that's still going on as a debate. And what's one more interesting thing I've seen when it comes to the blockchain debate is what's around proof of work versus proof of stake. Again, to put it in simple words, if each of you are running a node, which is one of the blockchain, you're actually taking a lot of energy. It's because it's trying to solve a specific problem. So as soon as one of you solve a problem, you have the authority to put the node in a chain. So this is what happens in a public blockchain. But in private blockchain, because there's only maybe 4 or 7 or even 10, depending on how many people came together and created this private chain, you're probably using less energy. So there's this huge debate happening right now today in the world of blockchain in terms of should we be using a public blockchain or should we using not public blockchain, sorry. Should we be using a proof of work or should we be using a proof of stake? And this is one of the key area where I'm really interested because one of the areas where my focus right now is climate change, and climate change is a key topic for every single company and every single government as well. So without going further, let me jump straight into Web3, because I think this is where it's more interesting, where the whole concept of blockchain starts coming to life. So what is Web3? I think if you just Google to understand a bit more about Web3, some of the simplistic example which you would get is, there was a time when internet first came in, just like how you have newspapers, what you can do with newspapers, you can just read. So that is exactly what Web 1 was, where you take the entire content, you put it onto the web, and people can actually read it. So the goal is to learn and understand and knowledge. That was the goal when it comes to Web 1. But when it comes to Web 2, the idea is you start moving more towards more advanced websites. And I think this is where some of the common example which people give is how Facebook, Instagram, and all the new apps started coming and websites started coming, where the goal is not just for you as a user to passively sit down and absorb this information and build your knowledge. The goal is for you to actually share, be part of that conversation where you are actually sharing stuff and you're building it together. So that's where I think more and more Web 2 companies are being framed as, this is a company which belongs to Web 2. But in the world of Web 3, what is really interesting is the focus is more around the data. Because if you predominantly look at most of the Web 2 companies, they tend to take the data from you. They look at creative ways of monetizing it. And end of the day, the value is kept by them. You as a user tend to give away that value to those companies. And I think some good examples comes when it comes to how how incentive is actually shared. When I say incentive, let me take an example of Facebook and Instagram. Every time you upload a picture and you become a very good influencer, you built hundreds and thousands of people around it, or even million. But the actual incentive of creating it, say for example, Facebook or Instagram would keep it. But when you look at Google as an example, where they would probably share a big chunk of that incentive back to you if you're a YouTube blogger, so that you actually get a big piece of that monetized value back to you. But when you look at the Web3 world, what is really interesting is they don't keep too much of the value to themselves. They actually pass it back to you. So there's a lot of companies which probably keep somewhere around 2.5%, 10%, or even 20% sometimes, and the rest they give it back. And this is where it's really interesting, the ethos of Web3, of saying that if you as users come on a Web3 platform, the value is given back to you. And I think that requires a completely different mindset as founders who are creating these Web3 companies, because it's not easy to say, I'm going to give away 70, 80% of the revenue, especially when you're not even making money. So this is a really interesting mindset, thinking a bit more long-term, thinking a bit more about the community, members. So this is where the concept of community is at the heart of Web3. As I said, I think there's a lot of simplified version of what Web3 is. And the reason why I actually picked up this is This was what do you call it, formula, which came up, which was shared couple of, I think, a year ago, which resonated very closely for me when it comes to Web3. Because what this is showing you is they basically looked at all the Web3 companies and they found a pattern. And that pattern is what you're actually seeing here. And that's the one I'm trying to explain. So community is where at the heart of Web3. One more good example I can give about community is DAOs. DAOs is a very interesting way where people come together with a specific goal and they actually work on it. And I think this has been happening for quite some time. This is not a new concept which just started a couple of months ago just because people started talking about Web3. This has been around. Even when you look at the Linux Foundation, when you look at the ethos of people coming together, building software together, they all came with a purpose and they started working on it. But what's happening interesting now in Web3 is more and more people are coming together with so many different types of purposes. And that's why we see how a group of people coming together maybe to raise money together. And that's really interesting. And in my case, when it comes to what I'm doing, I'm seeing a group of people coming together with a very simple mission about how to fight climate change. So this is where I think there's going to be a really interesting movement which is happening, which I'm already seeing all around the community, how people are actually coming together. Because I think civilization has always progressed depending on how people have come together and worked together. And that's a theme and that's a trend which I'm seeing, which is really interesting. And for people who are young, who have just started, probably not had any work experience or just coming out of the university, Web3 gives a lot of fantastic opportunity where you can actually work on multiple projects and actually get experience. So if you worked in, say, a DAO or multiple DAOs for maybe 6 to 7 months, it's more like you've got 2 to 3 years experience. Because if you work for a typical corporate, you would be focusing on just one area. But when you work in the DAO, you have a choice to work on multiple projects. And that's very rich in terms of experience. So this is why I think community is a really interesting thing in the Web3. And it's at the heart of what's happening in the Web3 movement. So that's the DAO, which I was explaining. And again, the best thing is people don't have to be in the same room. They can be from anywhere and they can have any background. This also has some challenges, especially on the identity space, because Web3 allows you to be part of the community without even revealing who you are as an individual. So if you're a normal company and a normal way of running startups, that is quite a challenge in terms of where the people who are a member of your business are coming from. So it's not all great, it's a balance there. And that's something you have to watch out in terms of how you want to build your Web3 company. Autonomy. So this is the second core thing about Web3, which you don't really get to see in a normal corporates. And for me, what is really interesting about autonomy is you allowing your members, that is people who are part of your Web3, to make decisions. And again, this is one more thing which is not easy for founders to give away. If somebody decides to build a group of people coming together and as a business, they would like to hold on to the decision-making power. And so this is, for me, a mindset thing, where when people start thinking about building a Web3 company, are they ready to give away that autonomy to the actual members? And a good example for me is John. So I've known John for nearly a year now. He is a Revlon influencer. And John is actually interested in launching his own hair care product. It's a shampoo, a hair conditioner, and oil part of it. And John is actually looking into Web3. So Web3 is not just for people in the tech. It doesn't matter which industry or background you are. If you have a really interesting idea and you want to bring people together, that's an answer for you. So for me, in this case, John's been thinking about launching his own product, and he wants to make a decision on, say, what kind of packaging I need to use for my hair care product. So he is willing to let his members decide on the direction his business is going to go. And those are the kind of things which is not easy, you as a founder, because it's a mindset thing about letting go that power to make decisions, trying to be a bit more democratic. So you can always watch his talk on TEDx. You can just type John Riel and you can find his talk. But this is a really good example I just wanted to say, where he's actually going to let his consumers vote in terms of what kind of packaging he should be creating, in terms of the formulation, etc. So yeah, this is just one example around autonomy, giving that autonomy to the people who are part of that membership club, or even consumers if you're building a product. The last one, this is my favorite, but this is equity. What I want to talk about equity here is tokens. Why is this really important in the world of Web3? When you try to bring a bunch of people together, what they're actually giving you is their energy, because they're volunteering. They're actually coming together with a mission and a purpose. But there's only so much that intrinsic motivation can get people. And this is where at some point you have to start thinking, can I give anything other than an opportunity, a platform, anything other than, work experience as an example. So this is where the question comes, what is it that you can actually give people in return? And because most of the Web3 startups use blockchain as the underlying layer, they can always create tokens. And these tokens could have a value. So if you decide to run your own Web3 company or a group of people as a DAO, you will always look at tokens as a mechanism to incentivize people for the hard work which they are doing to be part of that mission. So this is where I think the tokens plays a key role. And this is where nearly every single DAO today uses tokens as a way to incentivize people. It might not mean much at the beginning, and this is why I think people are going to start spending more time looking at projects, and they'll probably start vetting which projects they would like to spend time, put their effort, etc. Because end of the day, by betting on the right project and working on the right project, your token value is going to go up. So tokens are definitely another key incentive mechanism for people in the Web3. So in short, if anybody asks you what the Web3 is, there are three simple things I want you to take away. One, it's all about community, which is people at the heart. Two, it's about autonomy. It's not just people coming together. People coming together and they have the power to change and set the direction. That's what autonomy gives them. And the last one is equity, which is they get something in return. And that's where the token concept comes in. So anytime you hear this is a Web3 company or this is a Web3 startup, these are the three elements which will play a key role. So that's the most simplistic explanation I can share. And I just love this explanation because it touches the three things what blockchain is actually helping. So as I said, most of the DAOs, how people come together, they're probably using a smart contract, which brings people together. When you look at autonomy, people are voting. Where is the votes happening? It's happening probably on a blockchain if it's on chain, and you can see who's voting what. And of course, the last one is the equity when it comes to the incentive side. So those are the three key core things which makes Web3 what it is. So the last one I would share is, if you would like to know more about Web3, I'm actually running a full 3-hour event on Web3 with someone called Web3 Gen, where we are actually going to be explaining different concepts of Web3, which you just saw, which is community, autonomy, and equity. So that's something which we are planning to do on 23rd. So feel free to come back to have a much more deep down specific focuses on Web3. The second thing I would like to mention is this kernel community. And I think the last day for this kernel community to kick off is in October. This is a great way to learn about Web3 because you are basically tagging along with other founders. You're tagging along with other people who are also interested in Web3, and you can form a group and you can actually learn. And this is an amazing, group or resource if you're really interested in Web3, which I would love to point out. And the last one, if you would like to be inspired, I'm actually inviting a couple of people who are who've done some really cool things around Web3 when it comes to environmental NFTs, when it comes to metaverse. So yeah, I'm running a TEDx around October 17th. So these are three events which I'll be pushing. If you would like to know a bit more deep dive and not the basics which I just shared, which really doesn't do justice because I've literally taken 20 minutes. You'll get a much more deep dive from experts who are in specific areas in Web3. That's it. Thank you. I'm just going to see what questions are there.
Yeah, thank you, Sandy. That was absolutely fantastic talk. It's amazing to see how blockchain is really sort of integrated in our everyday life. I mean, I'm a beginner to Web3. I know next to nothing about it. And talks like this is absolutely fantastic. So thank you.
Brilliant. I don't see any questions. So
no.
The question is,
sorry,
do I take any questions?
Yeah, take some questions. They're online. Pick a few.
There's literally no questions online. Fantastic. All I'm seeing is just hi. Hello from London.
Hello from everywhere. No, that's fantastic. So we will actually move over to the room. We'll take a couple from the room.
The talk was very serious. Don't you think that main use case of Web3 is entertainment? You know, money goes up, people can lose money, trade Elon Dogecoin, play on leverage. And also, I would like a more technical explanation of Web3. Like I would say, if I were to define it, I would say Web 1 allowed people to receive content from creators. Web 2 allowed people to
read and
share
write
content, like media. Web 3 allows people to share content and value in a decentralized way. That's what, like, the technological evolution also. Thank you.
Yeah, again, as I said, there are different ways of explaining what Web3 is. What I wanted to do is I wanted to give people something which they could remember and take away as a core 3 concept, which actually makes Web3 what it is. For me, it's all about community, people coming together, and it's about equity as an incentive, why they are together, because there's only so long they can go with that intrinsic motivation. And of course, the autonomy, just because you're part of a group, you're not just in the group, you can also set your own direction. And that's where those 3 things are at the heart of most of the Web3. And going back to your question on Web3, is it just for art or entertainment? Not necessary, because this is why I think we are still in a very early stage.
It's the main use case for now, much more than medical, let's say, that you mentioned there.
Actually, what you'll find interesting is, because it's about community, there's far more use cases which is coming up around community. And this is why you'll find it interesting to see what I and my team are doing around climate change, where we are bringing people together globally, irrespective of what industry they are around climate change, and bringing with that specific purpose around it. Cool.
Thank you.
Thank you. Any other question? Yeah.
How is it monitored when the decision power shifts to the community? How do we know if it's going in the right direction? So as a Web3 founder, how do you know if this, if the community is deciding something, whereas you have a strong feeling it should be something else? How is it that framework monitored?
I think delegating decision making is really hard. And that's at the center of most of the Web3 thinking, where you let things get decided democratically. And usually what happens in most of the Web3 startup is people write proposals saying, this is what we would like to propose, and the community gets to vote it. So personally, for me, it's not easy to let that decision power pass on from day one, which is why there's a concept of progressive decentralization, which for me is like progressive Web3. You don't do it on day one. Day one, you need to get a lot of decision made really quick. So you keep that decision-making power initially, and slowly you start looking at where it makes to hand over the decision. So in my own case, we have 14 communities with different disciplines. We won't let those communities make decision immediately. What we will do is we will let the community make decision for what they are working on, rather than making decisions on the wider Climatelink as an entity. So that's where we are going to do it slowly, progressively. And I think the big thing about Web3 is a lot of it is an experiment. It's you're going to try and you're going to see what works, which is why it's exciting, because people are coming up with so many new business models and they are seeing whether a specific business model works. And sometimes you learn the hard way, but sometimes you find something innovative. And I think you have to take risk to innovate. And that's something Web3 is doing at a very, what do you call it, supersonic way on steroids. So yeah, short answer, it's not easy to hand over the decision, which is why I think you need to do it slowly. But some Web3 startups starts as a DAO, and from day one, they tend to do it. I think it really depends on what use case you're trying to work. Personally, for me, it's not easy, but we are working on it to hand over the autonomy.
So in the community, when people put together the proposals, is that like a voting system or?
Yes, it'll be a voting system.
And ultimately, if it's implemented or if it's chosen to implement, it's sort of like if the value of the token, for example, decreases because of so-and-so decision, then I guess it's the community that's like, okay, well, we...
Again, short answer, because we are running out of time, short answer is yes, if the token has value. But there are communities where token doesn't have a monetary value. It's just a utility. If you have the token, you can enter a specific community. If you have a token, you have a certain reputation. So it's a bit more beyond monetary value. And that's where it makes more sense rather than just monetary-based crypto values.
Thank you.
Amazing. Right, I think that's it for questions.
And again, just get a hold of me if you have any questions after the session.
All right. I mean, if you have any more questions, we have a break coming up after the next talk. So please feel free to grab Sandeep afterwards. And at the end, we have a networking session as well. So up next, we have got Ali.
Hi, everyone. Good to see you all, London, although it feels like winter to me. Is this really summer? I've been saying that all day, but thank you so much, Sandeep, for that introduction as well. And I think it's really important to note that this is about community, and that's how I see technology in general as well before I even get started. We're building technology to make things more efficient as humans. Like, we're building it for ourselves and our social structures. That's the point of technology in general. So I liked that you really had community in there, and we're trying to figure out how do we organize as a community for a common good. So hello, just thought I'd add on there. I have great questions from the room as well. So I'm Ali. I'm a developer advocate here at the Filecoin Foundation. Fun fact, I also used to host a podcast and work together with our host here, Liam Hampton, and also one of our other speakers, Matt, and I only actually met Liam yesterday, though, for the first time. So we worked together for years. First time I met him was yesterday in London Street. So it's amazing to be here with both like old colleagues and new colleagues as well. So colleagues from Protocol Labs, Filecoin, and also NFT.storage, Filecoin Foundation for the Decentralized Web. So stoked to be here. Long introduction. Sorry all, let's get on with the agenda. So I just want to run through some of the concepts of IPFS and Filecoin for those that might not know them in the room. And I actually am consolidating this talk because unfortunately Konstantin, another one of our speakers, couldn't be here. So for those of you that were looking for a deep dive on NFTs, I've had to like kind of make that a bit shorter, but I'll point you to some content where you can find more on that online as well from previous talks of mine. Yeah, and basically I'm going to talk about IPFS, Filecoin, brief intro to NFTs, how you would make one, why IPFS and Filecoin are useful for them, and let's get on with the show, I suppose. So I want to start here. Firstly, Filecoin and IPFS are actually part of a larger organization. And is my mic still working? Oh, cool. Sorry, I just went quiet. And both of these projects were originally incubated by Protocol Labs. So Protocol Labs is a fully distributed open source research and development lab, which was founded by Juan Benet in 2013. And it aims to build protocols, tools, and services to help radically improve the internet and drive breakthroughs in computing. And we're not just saying that, like we actually mean it. So Juan Benet has been hosting these and building these tools and really putting all his effort into building this community behind actually creating things that make for a better future. And we've got a lot of things out there around that as well. And that goes back to my original comment on Sandeep's talk as well. Alrighty, so IPFS and Filecoin are two of the projects that were originally incubated by Protocol Labs. So both IPFS and Filecoin could be classified as fitting into the data part of a tech stack. And as you would all know, data is absolutely essential in our daily lives, and Sandeep touched on this aspect as well. It's also a super fast growing field in Web3 because enabling distributed storage mechanisms can also enable many new applications and use cases to be built with more permanence, with trustlessness, and with more resilient outcomes and censorship resistance. So we don't have to look too far to see why that's important. If we look at current models of data storage and sharing, Sandeep also touched on this. If you are not paying for your data, you're the product, basically. If you're not paying for a service, you're usually the product. We've all heard that, and it's true. And that's one of the issues of the current data storage model. And the other one is that we're kind of storing a lot of our data centrally. So this is a resilience engineering problem as well. So it leads to a lack of security and portability around our data. And not just for individuals, but also for businesses. And another problem is that if any of these storage systems fail, these centralized storage systems fail, which we've seen happen, entire services go down, like big services like Twitch or other ones. So this issue is a resilience engineering challenge, as I mentioned, and you could perhaps start to architecture, and probably some of you do, with microservices, multiple databases, and maybe you run something like Red Hat OpenShift on your Kubernetes containers and create like this multi or hybrid cloud environment. But by this point, you're kind of diving into decentralization and distributed systems already. And this comes with some massive engineering and financial overheads. And that's just for the resilience challenge. We haven't even started to solve the problem of your data being owned by others. So this leads to the question, right? Why aren't we designing the web for the autonomy and resilience that we need in the first place? And how do we get to a world that has a resilient, a performant, a scalable, a censorship resistant, and an open web, which was really the mission in the beginning of the web. So these are the kinds of problems that we're trying to solve at IPFS and Filecoin, and why we're so driven, together with the community, of course, to do so. And we're not just trying to solve these problems for Web3 either, but this is also for traditional tech in general. So let's get into some of the concepts. So cue the Star Wars music. What is the Interplanetary File System, or IPFS? Well, this isn't just a meme name, it's a distributed peer-to-peer network for files and folders. So IPFS was designed to be able to work even when the network's between planets. So let's say you signed up for the Mars Colony program and you're now living happily on Mars. Maybe it takes you an hour or so to request a file from Earth that you need. But if someone else on Mars already has that file, then that person can just give that to you instantly instead. So maybe you're thinking, well, that's just a fancy story for a peer-to-peer network, but there's real gravity. Yeah, sorry, couldn't help it. In what it does, because IPFS is distributed by design, it has no central authority servers, it's designed to be used offline first for resilience, and the important and unique thing about it is that it uses a really unique and upgradable standard for addressing content. It's this content addressing system that's really what makes IPFS unique as well. So rather than using methods we might be familiar with for storing and accessing content, so you go to a HTTP address on the web, that's location-based addressing, and the content at that HTTP address could quite easily change from day to day. So someone could swap out what that content is on that particular website, for example. That's location addressing. So instead of doing that, we're content addressing. So that means that you can be sure when you access an IPFS content ID that you'll get this exact same piece of content every time. And you also don't have to care where the data comes from then, right? So this idea is kind of wild to me when I first started looking at IPFS and Filecoin, because it's really such a mind shift from how we do things in the day-to-day and what we're really used to and what we're accustomed to at the moment. And it's really super elegant in its simplicity as well, because just shifting that focus from a location-based address to a content-based ID opens the web up to those massively distributed storage solutions. So content addressing kind of works like this. It just makes a cryptographic hash of the content, which you can kind of also think of as a cryptographic fingerprint, to create a content identifier, or CID for short. And for each piece of information that we want to put on the network. So that means every piece of content has its own unique CID. If I upload a meme image and it comes back with a CID, and I then go ahead and change 1 pixel of that image, it will be a different CID. So again, just to reiterate, A content ID is a unique fingerprint for each piece of content. If the content changes, so does the content ID. And to quickly note, this content addressing system works for all content, including like folders. It's not just limited to JPEGs. We can even represent full file systems using content addressing structure. And back in 2017, we actually stored all of Wikipedia on IPFS when Turkey's authorities blocked the website from being served in the country. It was snapshots of it, but still, we served the whole of Wikipedia on IPFS back then. So the main thing to understand is all this protocol and networking logic is really what makes IPFS an important and valuable protocol. And Dietrich will definitely show you how that works in not just Web3, but also what we're doing to put it in other weird and unique places as well. So this protocol is being used not just by the Web3 world, but also by the Web2 world as well. So the thing is with this peer-to-peer protocol, we kind of come up against a problem that the early web also had. So you either have to run your own IPFS nodes, and even if you are running your own IPFS nodes, it's pretty easy to do. You can do it on desktop or in the browser. If you close your laptop though, all of a sudden that content is no longer available to the network. So what if you don't, and also what if you don't want to be running your own nodes and storing your own content? In that case, you're kind of expecting someone else to be keeping a copy of your content around. And why would random people help you store your digital content? So unless they like you, or maybe you have a piece of content that they really like as well, or is super valuable, like climate content, for example, then they probably won't. So despite the usually good intentions of a community, less popular pieces of content probably stop being hosted and will no longer be able to be retrieved. So the other alternative is you might want to pay someone to keep copies of your data, for example, through a pinning service like Infura or Pinata. So this isn't a bad option, but if we extend this into the future, we're now kind of creating a world of incentivizing centralized data models again, which leads to that resilience problem that we started out with and a loss of the trustlessness that we're aiming for as well. So how do we ensure that that is not a problem? Well, this is really where Filecoin comes in. So Filecoin is basically a decentralized storage system designed to leverage the crypto economic incentive model, which Sandeep was also talking about. And it really is a crypto economic incentive model. So we will help pay to store your data, or I'll pay to store my data on several different things. That's a crypto economic incentive model, together with cryptographic proofs, in order to ensure that this data is stored persistently, reliably, and verifiably across a distributed network as well. So we currently have over 4,000 storage providers globally, and we make up 1% of the world's current data storage capacity, which includes the capacity provided by cloud storage providers. So we're the largest decentralized storage solution, which isn't bad for a project that launched in October of 2020. So Filecoin's use of cryptographic proofs is what makes it verifiable. So a consensus method like proof of space-time. I don't want to go too far down the rabbit hole here because we've got like a lot of talks to go and I'm hungry as well. But anyway, so the Filecoin network's also built on open market. So it uses it uses market deals to create incentives, which means that this data is always going to be cheap. So the more people that want to store their data with our network, then you're going to incentivize more storage providers to want to come online and take those deals. So it uses this market model for hyper-competitive pricing. And in fact, the average cost of storing like 1 petabyte of data works out to about $4 a month, or I think even less actually on, actually there's another stat up there. But anyway, it's super cheap, way cheaper than a cloud, sorry. So that's enough. And we're also internet scalable as well. So we're aiming to make sure that this is a big data network. It can be a distributed network that can store big data. And we're already doing that as well. So I've given you a brief overview on IPFS and Filecoin and how they work together. So IPFS offers that content verifiability with fast and flexible retrievals over that peer-to-peer network, and Filecoin offers verifiable data persistence and resilience at internet scalability. Just a side point here, and I think I've quickly noted it as well, IPFS is a protocol, not a blockchain. So it's storage layer agnostic. which means you can combine it with the storage layer of your choice, which could be Filecoin, obviously a great choice, but you could also store your IPFS data with Microsoft Azure or other clouds, or even with decentralized data storage solutions. All right, the bit that maybe I was going to start with, what's this all got to do with NFTs? Well, NFTs have become like a massively noisy story. There's been a bunch of celebrities creating NFTs. There's been millions of dollars going on these. It's all been very speculative in a lot of instances. There's been celebrities and big brands everywhere cashing in on this or trying to cash in on this. And releasing their own NFT collections, and even auction houses like Sotheby's have got in on the game. So there's really been a lot of noise and hype going on in the NFT space. And when you start your NFT journey, that can be a little overwhelming or even off-putting. So what exactly does NFT mean? For those that might not know, it's a non-fungible token. So this means that unlike the cash in your pocket, which you can exchange, that's fungible, non-fungible tokens, they're cryptographically unique, you can't exchange them. The Mona Lisa is not equivalent to the girl with the pearl earring, you can't just swap them out. That makes them non-fungible, or collections of non-fungible tokens, basically. So that's a brief explanation on what an NFT is. And also I want to get into why it's important that when we think about NFTs to not just think about this JPEG narrative that's been so popular the last year and what it is that's really underlying why NFTs are important. So they're far more versatile than this kind of NFT speculation bubble that you might see on the surface would have you believe. And that's because of these 6 main properties. They're unique, they're provably scarce, they have guaranteed ownership, they're transferable, they're kind of, well, fraud resistant, and they're indivisible. So this all means that they are like a digital fingerprint, digital signature, for things. So they can be used in so many applications, and off the top of my head, these are some of the ones that they're getting used in. So tickets, certifications, patents, with guaranteed provenance, voting and governance rights. So we were talking about that with Daos, for example, earlier. NFTs can be used for that. They can be used for new identity models, for charity, with resale royalties. So one of the cool things about NFTs these days is you can inbuild into the code royalties that have to come off this every time they're transferred or sold, which means you could make a charity NFT or a music NFT, or a Revlon NFT, for example, that every time that gets sold, a piece of that has a royalty involved in it, creating this artist market, for example. And that's just one way that it could be used. There's people using these in real estate as well. I know IBM, where I used to work, is using these in their patents. So there's lots of different ways that NFTs can be used. So I encourage you to dig past the NFT as a JPEG narrative. But anyway, let's dig into the anatomy of an NFT contract as well, for those that are interested. The standard NFT contract at the moment is an ERC 721, at least on the Ethereum network. So if we have a look at this contract, there's a whole heap of implementations out there, and we don't start from nothing. I would encourage you to start from a contract that's already been implemented and audited by the community, and which is why I've got the OpenZeppelin docs up here. So OpenZeppelin has a bunch of Ethereum contracts that are already audited and community vetted, and that they keep updated on their site that you can just use and then add on to. So this would be the best place to start if you wanted to create a smart contract with Ethereum network. So anyway, this is like the ERC 721 Ethereum, ERC 721 OpenZeppelin, I should say, contract on there. If we have a look a bit further, it's just got a bunch of functions that come with it. Nothing too scary for the developers in the room here. In fact, here's an example of the ERC 721 contract. This is the whole contract. This is it. So pretty interesting, right? If we have a look through it, they've just imported the contract. Obviously, that comes with a few extra APIs that aren't shown here. But the main thing is they've got a counters, which just gives you the ID for each of the NFTs in this collection that we're going to make. We've got the construction, and then we've got the function award item, which is really what's minting your NFT. And it takes in the address of a player, which is who the NFT is going to belong to after we mint it, basically, or after we call this function, which is really minting the NFT here. And it also takes in this string called a token URI, which is also important. And it returns like the UINT 256, which is just the identifier for the NFT, which would be 123 in this case. And then it mints this token with the address of the player down the bottom here and the ID, and then it sets this token URI. And that's it, we've minted an NFT. But what is the token URI here? Because really the token URI is what's giving this NFT all its kind of visual data, or it's like descriptive data, or what we'd really be interested in when it comes to an NFT. So in this case, they're talking about a game item. So it's called Thor's Hammer. It's got a description and it's got an image here, and perhaps it's got other attributes like a strength characteristic or whatever you want to add on to this. This is all a token URI is. It's just a JSON document. It's an object. But the problem with this kind of this JSON object is, and probably someone can point it out for me in the room here, like I think these guys are laughing at the back here, but this image, which makes up like a core part of our NFT, we would think, is location addressed. Doesn't that all of a sudden make my non-fungible token fungible? So OpenZeppelin actually already notes this as well. So if you're not storing this object on-chain, which you can do, but it can get prohibitively expensive if you're trying to store videos, 3D objects, something like that. But if you're not storing it on-chain, basically you're opening yourself up to something like this. So these are some famous things that have happened with people that haven't or have deliberately used location addressing in their NFT metadata. So the first one is this guy released a whole collection of NFTs which sold out, and then he literally swapped them out for rugs, creating a literal rug pull on the NFT collection for anyone that had bought them. Now, if this had been on IPFS, it would have been, you wouldn't have been able to do this, but because he had this location address, he was totally able to do this, or he could have also coded it into his contract. But that's not what happened. The other one, he used his current NFT collections to advertise his upcoming NFT collections. It's called F-Bubbles. I think we all know where the blanked out bit is, but so it's called F-Bubbles, and yeah, he used it as an advertisement. So he'd sell these NFTs and then he'd go, hey, I've got another NFT collection coming up, go here, and change out the writing on that. So unless you deliberately want your NFT collection to be kind of dynamic like that, then this is why you want to be using IPFS and Filecoin. So firstly, like I mentioned, you need storage that's off-chain. So on-chain can get really prohibitively expensive, especially on Ethereum mainnet, and particularly for large files. You want to store audio, video, 3D images, all sorts of different data sets. It's not going to be, you can't really store that on-chain, which is the only other way to make sure that this is a non-fungible token. So you need a fixed address for the content that assures immutability instead, which is where IPFS comes in. And then you need storage that's persistent and reliable, preferably for hundreds of years. And Filecoin decentralized storage can guarantee this verifiably stored persistent data. Alrighty, so fortunately, you don't have to go and make an IPFS and CID and then make Filecoin storage deals and perpetually renew them for any NFT contract you make. There's a great product, and I think one of the devs is here tonight actually wearing a hat on, looking at his computer and coding right now. Yep, that's him. He didn't want to be called out. But anyway, so NFT storage will do all that for you, and it will store with 8 times redundancy, so making sure you've got 8 times storage deals. And it will compute that CID for you. So if you do want to try and make an NFT, I encourage you to have a look at nft.storage. The best part about it is that it's also free. So you can go ahead and use that and try it out. It's free because we're funding that as a public good for multiple generations. We see the value in NFTs. And we want to make sure people are doing it right. So even the big NFT marketplaces, if anyone's in this game, like OpenSea, are using nft.storage under the hood. So it's really become, standard as well. So, alrighty. So I think, how am I going for time here? Maybe a couple more minutes. I'm just going to jump through some use cases for IPFS and Filecoin. And what's next for us as well, because obviously our use cases aren't just about NFTs, but that is a good use case for IPFS and Filecoin at the moment, and there's some other examples of how we're using it. But there's also a heap of other people using IPFS and Filecoin, both in traditional tech world and in the Web3 world as well. So we're storing a heap, I don't even know how many 100 plus petabytes of useful data is, but a lot. And then 4 million, we've got 4 million current deals on Filecoin as well. We're doing things with people like Flickr, with OpenSea, like I mentioned before, with Zora, which is another NFT marketplace, with Docker, and a lot more. And I think Dietrich will also give us some examples of things we're doing with IPFS too. So another use case is for metaverse and gaming. Obviously, open metaverses are going to require something like NFTs to operate or to have gated communities. So we're working with some of the metaverse community to help with that, as well as you're going to need avatars in there. So if you own your own NFT data, and I saw an interesting project at a hackathon over the weekend that was layering avatar information and saving each layer as an IPFS CID, and then minting that as an NFT at the end. So it was like called Do Character, an avatar-based kind of thing, which is super cool too. The next thing is, like I mentioned earlier, we really do care about trying to do good. And one of the great use cases, which Sandeep would attest to here, of public blockchains, is that you can track things through them and that they're immutable and verifiable and transparent. So not only are we trying to make Filecoin, our actual blockchain, carbon neutral, and we're doing that by incentivizing our storage providers to have renewable energy but to use renewable energy for their storage and data centers. But we're also trying to create projects that will help us track energy use and incentivize green energy. So not just creating carbon credits, which kind of, do solve some of the problem, but they, don't really incentivize you to use green energy in the first place. They basically just go, well, I'll go green by buying some carbon credits. So we're trying to do some things around that. And the Filecoin Green team is amazing. So check out some of their lectures if you're interested in that. The other thing we're doing, we actually have someone from this part of Filecoin here tonight too, is the Filecoin, yep, there he is, not afraid to say hello, that's Steph. Hi, Steph. So the Filecoin Foundation for the Decentralized Web. It's a non-profit, so a complete charity. We're not trying to make any money here, but we're definitely trying to nurture the development of open source software and store some really valuable and important, and Steph can probably tell you later, so ask him if you want to hear more, but preserving some important data sets, so some of which are from like Starling Labs, Holocaust victims. We're doing some things around UK crane data at the moment. We did some stuff with the Internet Archive, storing websites and important information around there. And obviously we're storing a lot of climate data as well. So there we go, we've got some Web2 data sets up there. Some of the things we're doing, I mentioned Internet Archive, climate data. So we're doing things like that through the Filecoin Foundation for the Decentralized Web, and they're doing an amazing job too, and can tell you more. So what's next for us as well? One of the things, we are a verifiable decentralized storage system at the moment. The next thing that we want to do is add a CDN on top of our storage system. So we're trying to create a retrieval network which will enable everyone to be involved through your browser in retrieval and create really low latency retrieval of the data. The other thing we're doing, which I'm super excited about, is creating programmability on our Filecoin network. So we already have kind of the layer 0, which is the Filecoin decentralized storage system. And now we're going to create like programmability or compute over data on that system. We're going to create smart contracts basically to go with our storage network, which will enable so many cool use cases. So that's called the Filecoin Virtual Machines. Keep an eye out for that as well. Oh, there it is. Fancy that. Anyway, it's going to enable a bunch of use cases, not just around NFTs, but around, user profiles of data. Anyway, so many things. There's a lecture up on YouTube if you want to hear more about that as well. Heaps of projects in the Web3 and Web2 world built on IPFS and Filecoin, as I mentioned, so, and enabling those creative markets. So Audius is like a decentralized Spotify, OpenSea and NFT marketplace. LivePeer is actually live streaming, but censorship resistant live streaming and SDK built on IPFS and Filecoin, so heaps of cool things. Huddle01 is also like the Zoom of the Web3 world. So some cool stuff happening in the Web3 world and built on our stuff. If you want to know more, Proday.school is a great resource. NFTschool.dev is also a great resource. Or join a hackathon, hackathons.filecoin.io as well if you want to get involved. I think that's all from me, which is lucky because I think I'm at time and we're all hungry. Okay.
Thank you, Ali. That was a fantastic talk. And
Thanks,
a massive thank you to
Leah.
Filecoin for sponsoring.
Hey,
meetup
sponsoring
today.
the food anyway. So thanks
and
for
yeah,
hosting
and,
us. I don't think there's any questions from here, so I'll take questions from the audience
no,
instead.
fantastic.
If
We've
there
got
is
a couple minutes
Sure.
to take a few questions, and then I can see everybody's eager to eat.
Yep.
We've definitely got plenty of food for everybody. We've ordered some grilled chicken wraps, some falafel wraps, some everything.
Fried chicken wraps
fried
too.
chicken
We
wraps,
ordered
you name
heaps
it,
of
it's all
them.
there.
Yeah.
Not to make you even more hungry for the questions, but yeah, 100%. We've got some food. So yeah, we'll put it to the floor for some questions.
It's one over here.
One over
Awesome.
here.
Hello.
Hey.
How you doing? I have a question about content IDs and content addresses.
Okay.
Because following that at the start there, so
Mhm.
content ID is a hash of the content that has been stored on the IPFS.
Correct.
What's the content address then?
So it's just a content addressing system, which is a content ID. So sorry if that was not clear. I was
Right.
just trying to say it's content addressed,
Okay.
which is a content ID, if that makes sense.
No.
So content addressing is just that content ID. It's just called
Yes.
a content ID.
Yep. Okay.
So the IPFS protocol uses content addressing,
Right.
and when you implement that,
Hmm.
it's called a content ID.
Right. Okay.
Maybe
But I
Dietrich can
saw-
explain this better, but I'm not sure.
Well, I saw in the example that the
Yep.
content ID was used in the address to find the path to a resource on the IPFS. So
Okay.
if that hash is derived from the content that is stored,
Mhm.
and then I update that content, let's say, for example, I have an RSS feed in there somewhere and update it, how can people find the content they want that's relevant to the thing I'm distributing
Yep.
if the address changes because it's been updated?
Yep. Because I didn't have a lot of time, I didn't go into all of that, but it's definitely peer IDs and there's, yeah. We're asking a 10-minute question here, I think.
Okay, then,
Maybe Dietrich, do you have a
let's get, yeah.
Yeah, I think there's a
Right.
couple of things wrapped up in there, like what is a content ID and what are the different component parts of it. And to some extent, yes, simplified, it is the hash of the unique contents of that bag of bits, really. But there's also different things like you can encode it different ways. And there are also for very large pieces of data, you can break it up into many pieces.
Okay.
And those can be encoded in ways that allow you to have paths.
Okay.
The root ID and all of the IDs of the little pieces are immutable, so they do not change.
Right.
However, you can do things like IPNS, which is a way of pointing to a key which points to a unique ID, so you can
Okay.
update what ID that points to. And I think that's maybe a little bit of the first part. We could probably do, like Ali was saying, a few hours on that. In fact, a couple of these folks have done multi-hour sessions on exactly that.
Right.
But the second part of what you asked is actually different, which is around how do you find those people or nodes or machines or robots on this planet or other planets that have that. And again, there's probably a very long session on how distributed networks work. How do you search them? How do you index them? What are the different ways of routing around them to be able to find out exactly who's holding that? And a lot of that is kind of the internals of how these technologies work. And I think tonight there's definitely a little bit of the introduction into these things, but really unwrapping those, like we can definitely point you into like some of the sites that Ali just referenced have some of those explanations. Like there's one called The Anatomy of a CID on proto.school, which is really, really good reference that I point a lot of people to that explains exactly how the address itself is created.
Right.
And on that same site, there's some different approaches towards content routing that are just how the distributed hash table that powers the public network of IPFS and how that works as well.
Okay. Interesting stuff. Thank you. I will be reading a lot.
Yeah.
Thank you. Thank you.
We should do a whole day session next time.
I mean, it sounds like a plan. We'll definitely come back. Is it going to get warmer? No. Yeah, and
I
we can
think-
point you to that content too. I think maybe we had one more question, but maybe we'll answer it.
I was going to say, I think in the
Outside of
interest
this.
of time, maybe we go and grab a break now. Go grab some food. We'll maybe 10, 15 minutes. Call everybody back, and please grab Ali in the break or
Or
afterwards
Dietrich.
for questions. For everybody online, what we're going to be doing, we're going to go for a quick break, and then we will put the slides back up. We'll jump back on. So stay tuned. But about, what's the time now? 20 to 8. Let's say about 10 to 5 to 8. We'll be back.
Did you say yes? Somebody.
No, it should be. I have worked. I'm going to quit it. Oh, I think you said detrace.
No, the other one. There was
I saw that detrace. No, I've never seen it. I know. I was thinking the same question. Did I write that? Is it mine? Oh, yeah. For me? All right. Okay. All right. We'll wait another sec. There's some people walking this way. They look interested and interesting. I can see this is where I go off screen on YouTube. Right here. Yeah. All right. We got enough people to start rolling. Welcome, everybody. Thanks for joining. I'm going to talk a little bit about IPFS today. My name's Dietrich. I've been at Protocol Labs about 3 years. Before that, I spent over a decade working at Mozilla, building Firefox, building extensions, writing everything, different parts of the web, working on MDN, which is a website maybe some of you have used if you do web development. And I started doing some experimentation with distributed protocols. How do you write APIs that would allow a browser to be a full participant of some of these types of networks, whether it's a light client to a blockchain or an IPFS node? How can we make our browsers represent us more fully in our interactions online? A lot of this stuff that you're hearing about is still relatively new. So welcome to a world where things don't maybe work right all the time. HTTP has been around over 30 years. A lot of those cow paths, as they say, have been well trodden. How you build things is really well developed. The tools that we use every day all speak HTTP, and they don't speak IPFS. So what I'm going to talk about today is some of the challenges in building new things, getting people to use them, and how you actually have to engage with those people to be able to get those things to actually work. And we'll talk about some of the stuff that works and also some of the stuff that doesn't. So what does it mean to be a protocol? IPFS is a protocol. You learned a little bit about it in Ali's talk before. It's really different when you're building a protocol than to build a platform or build an application or build a website. You have to do a whole bunch of other different things. You have to be available in a bunch of different contexts. So HTTP you can call from inside a native app. Most native apps are actually just calling HTTP APIs in the back end. You can use it from a web browser, load a web page. You can do all kinds of things with it. You have IoT devices, and most of the time, even those are talking HTTP, not even some more appropriate protocol that they might be using to be able to share a bunch of sensor data out or something like that, right? You need to be available in a bunch of languages. You have to be where the developers are that you want to use your protocol. So that means implementations in different languages. We learned a little bit about this when we start engaging in the standards space, where we say, hey, can we get IPFS : / to work inside of a web browser? They'll be like, yeah, I've never heard of you. Go away. You're not HTTP, so you're probably not functional and not safe either. So just go somewhere else. So we start poking at that a little bit and asking questions. What is the process of getting allowed to be inside of a browser? And you start to learn a little bit about how they're thinking and making decisions. The browser vendors are making decisions, standards bodies are making decisions. So I like to add a third one on here, which is you need to be participating in standards bodies. You need to be part of the group of people that are having discussions about what technologies are okay for the general populace to be able to use. And that's how you end up getting your technology inside things like the web. How do we be part of the web? What does it mean to be IPFS? This also really changes. When you're a protocol, there's maybe not one full, complete, idiomatic, perfect, exact way that protocol is going to be implemented and present in all the technologies. If you're running inside an embedded device, you don't have the same type of memory or CPU or bandwidth maybe to be run in the same way as if you were on a server in a data center somewhere. So you have to make a bunch of changes around how you build what you build. And we ask this question a lot for IPFS, and as an example of a thing that is not quite done, is not complete. We don't really know where we're going to end up yet, but we always kind of start with this. the content addressing part of IPFS, which is what Ali talked about before, and we were asking some questions about at the end, is probably the cornerstone piece of the technology that would, like, you could vaguely describe something that addresses data in this way as maybe using IPFS or implementing the IPFS protocol or something like that. Because that one piece of IPFS is where almost all of the other benefits of the protocol actually flow from. The ability to uniquely identify content on a network and to be able to trust, not just trust, but verify that what you asked for is what you got ends up being really the most important piece in being able to build much larger networks and be able to think about what does an internet that lasts 20, 30, 40, 50 years need to look like? What are the worst parts of HTTP? How can we fix those parts? Almost all of that comes down to being able to trust that when you ask for something, that you will get back the same thing every time from that address. Because once you trust that you will always get what you asked for, you no longer have to care about where it came from or who gave it to you. You have to trust who gave you that address. And that's a whole different type of trust equation. The same thing happens in the regular web today. Can you trust yourbank.com versus yourbankwithatypo.com? There's a lot of trust issues on the web today, and so there's a different type of calculation that goes into the UX and design of security on the internet generally. But with IPFS, you can trust that if you asked for this address, you will get the same thing back every time. Whereas with HTTP, you can ask for the same URL over and over and over, and you can get something different every time. In fact, whole websites are generated around that product idea that is something different every time you load it. So it's a very different way of thinking about data. It's a different way of thinking about availability of data and the architecture of applications. When you're thinking about one address will return the same thing over and over and over. There's a lot of differences between this model, where you can do things like change what a URL returns every time, and this model, where you might have applications that need to run locally between devices that can only be connected through Bluetooth LE, or two devices or more devices that are on the local subnet, like connected to a Wi-Fi network that is not connected to the internet. And all of the use cases that come along with applications that need to be able to run locally without an internet connection, applications that need to be able to work offline, and applications where you want your data to be able to store it inside the application you're using, maybe locally to you, so you always have a copy of it. So with these architectural differences come all kinds of problems, all kinds of challenges. And the HTTP world asks really good questions that sometimes we're very ready to answer, and sometimes not so ready to answer, about what benefits IPFS has and what are the trade-offs that you make. And I think, even in this world where, let's say, you don't have the peer-to-peer aspects of IPFS, like Ali was talking about before, you still get some of the benefits of IPFS if you're just asking a centralized server for that data, but maybe not all of the benefits. And is that still IPFS? There are different aspects to this that you have to really think about, and oftentimes are dependent on the use case. What are you trying to build? Are you trying to build a game? Are you trying to provide information to people whose government has said they cannot have it? Are you just trying to make sure that things like Wikipedia stay available? Are you collaborating on really large data sets between a group of academics or scientists? Are you sharing machine learning models like we're going to hear about in the speaker coming after me? These are all different use cases that have different trade-offs in each one of these things. Most of the usage of IPFS, especially in NFTs, like Ali was talking about today, actually goes through an HTTP server, so very centralized, to get data from a decentralized network. It's the most common pattern because it is the most available way to get access to IPFS data. So some of these questions that I'm asking are really important when you're thinking about, what does my application need to do? What do my users need to do? If it's just two users in a desert who have some device, they need to talk to each other and they have no internet, that's a thing that you can do with IPFS. Is that still IPFS? Well, I think if you're using content address data in that application, then probably, yeah, because they can trust that data that they're sharing with each other a little bit more. Is it IPFS if you're going through a web server and getting data that is also on IPFS? Well, yeah, but there's also trade-offs that you're going to have to make, where that HTTP server that is serving data from the IPFS network might go down. Or like some of our really popular public gateways, their DNS gets turned off by various governments. Like the DNS of Wikipedia in Myanmar. Click, they turned it off. so they can't get to Wikipedia anymore. So even through the centralized access to data that is on a distributed network, you're just making a trade-off. And oftentimes, especially when browsers today don't support IPFS natively, you have to make that HTTP trade-off. So I'm going to talk now, so let's kind of study the stage. Here's some of the challenges. Here's some of the reasons why you'd want to use it. How do you actually get it into people's hands is a whole another problem. So I'm going to talk about a couple of the implementations, ways that you can use IPFS today. The first is Go IPFS, which is an implementation of IPFS protocol that is really the kitchen sink implementation. It's the workhorse. You can run it in data centers. If you install the IPFS desktop application, it will install and run that node locally. If you install the Brave browser, that actually has a feature where you can download and install a full IPFS node, this implementation, and run IPFS on your computer built directly into the browser, which is really interesting. And we're seeing a lot of use cases addressed there because of the ease of use. Again, it's very easy to be able to access the technology in that way. Another one of the major implementations is JavaScript implementation of IPFS. Again, it has some limitations. It doesn't have the full capability set, the full range of capabilities that the Golang implementation has, but it can do all kinds of other things. And also, JavaScript is basically the most popular programming language on the planet. So it is available to the most number of developers. Well, that and Python, so sorry, Python people. And so there are trade-offs. You don't get the full capability set, but it can run in a browser, but maybe not all the way, right? So you're always making trade-offs when you're building these types of applications and when you're thinking about how to get your technology into the hands of people. So there's a bunch of other implementations and other varying languages to varying levels of capability available for IPFS. And you'll notice I keep using this word availability. And one of the things, this is a diagram of CSS grid. And if you're a web designer or developer, you're really familiar with the fact that actually laying things out on a web page was pretty much terrible for about 25 years until CSS grid came along, was built into all browsers by default. But CSS grid actually really was available in Internet Explorer in 2012, and even before that. But designers and developers on the web couldn't actually choose it. They couldn't use it because it wasn't available in all the web browsers. And one of the things that we learned when I was working at Mozilla, and we did a bunch of research into what actually allows a designer or developer building technology today to make a decision to choose a technology. And what we learned is there's basically a threshold of availability. If that technology is available at a certain threshold in the audience that they care about most, and with the internet, that means pretty much all the people most of the time, and especially depending on some product managers, but that's a different story. The availability of the technology is a key factor. And one of the things that we realized is that if you can shorten the time that you can get that technology into people's hands and get to that threshold, then you have a much, much, much higher time, better time to market and getting your technology into people's hands and developers actually being able to choose it. So if it's not ready yet and you can't get it to where people are actually building stuff, then it's kind of, all this is really ends up being really obvious. Unless people are going to actually choose it, if it's not available in the places they actually need to build things, ship things, deploy things, talk to their boss about it, talk to the designers about it, all this kind of stuff, right? And so back to this slide and why it's so important that IPFS needs more than one implementation. It needs a full spectrum of capabilities in a wide variety of environments, in a very long list of programming languages. And that's one of the things that makes it a protocol, not a single implementation technology. So I'm going to talk now about a couple of the things that me and my team, the Browsers and Platforms team, Protocol Labs, do to try to get IPFS out into these places. So obviously browsers, I worked there for a long time making browsers. And so it's very interesting to me, how do you get browsers to make decisions to adopt the technology? I talked a little bit about standards bodies and things like that. A lot of it is actually like dark matter, like how are you participating in their GitHub repos? Are you filing bugs? Do they have a relationship with you? Are you in the room when they're making standards decisions at W3C? You don't even have to be in the room. They know you contributed on the mailing list. Sometimes that a little bit conversation goes a long way, right? We've made some inroads. Like I made this and I was really surprised at how much green there actually was, given how long it takes when you go back to the CSS grid slide. Like even something that is not contentious, like improving layout, takes years to develop, years to get into people's hands. Now we're talking about a full-on revolution in the paradigm of network security, of user security on the web, of architecture of the networks, of how browsers are built. everything from DRM to free availability of data on the internet, of actually making censorship mitigating technologies that could be even dangerous for the people that need them the most. Like, these are really, really hard problems. There are reasons why they're not easily solved and they're not widely deployed yet. How do we get there though? How do we understand what those trade-offs are? And a lot of it is really just like keeping all of these streams going, talking to all these people and working with them to be able to get there. It's not easy. And it's going to take a while, but there's really a lot more green there than I thought. So I mentioned Brave before. They have a full implementation of IPFS. You can install it. They have basically they'll use an IPFS HTTP gateway by default, but you can actually like click a button and it will one-click install an IPFS node. We have a full-time engineer working on their team, which has really worked and has been a great way to build trust and relationship with them. And we're doing a bunch more stuff. There are going to be a bunch of NFT features coming. They just launched a native wallet earlier this year built into the browser. And just last week or a week ago, Filecoin is now supported in that wallet in Brave. So you can have native support for that as well. Chromium, you know, Liam, you made me do this presentation on Chrome, which after working on Firefox for long is making me a little twitchy, but it's really important because Chromium is basically the web rendering engine that over 90% of the people on the planet who ever open a web page will be using. So native support for these types of technologies and protocols inside Chromium is something that's very, very important. But as you can imagine, it's also not easy. It's going to take a long time. It takes a lot of work. Just even building up the trust with these communities to be able to have these conversations takes a lot of time and investment. So we partnered with a group called Agalia, and they have basically, they work on all the web rendering engines, all the open source ones. They work on Gecko, they work on WebKit, they work on Chromium, and we work with them to be able to slowly chip away at these problems. And now, I think as of maybe 2 weeks ago, you can actually download the Chromium source, and we work with them to kind of like refactor the entire pipeline of how addresses are handled up and down the Chromium source tree. So now you can bundle in support to a Chromium build that you make yourself, support for something like IPFS, where something that is not HTTP or HTTPS actually has the right privileges checks and the right security checks and the right all these other things. Because before, when you did that with Chromium, like Brave had done or Opera had done, you kind of had to like pop around and put it off to the side over here. And there's like Chromium's regular security pathways that you go through and everything up and down from the graphics rendering stack to CSS parsing and all this stuff. And it kind of just jogged around the side there, skipped all that. But the work that we're doing with Agalia brings the ability to have non-HTTP protocols more natively supported inside the browser. It's very far from something like native IPFS support, and we don't really know what that fully looks like yet, but it not only helps us when wanting to do IPFS in Chromium natively, but helps any other non-HTTP protocol that's interested in going down this pathway. So we're kind of like investing here in a way that makes all of the distributed and decentralized networks boats float a little bit for this work. IPFS Companion is a browser extension that you can install today. It does some really nice things. If you're running an IPFS node locally, it can do things like ease access in the browser for web applications to that node. It does a couple of other things. However, with the advent of Manifest v3, which is a new format of extensions that Google and all the other browser vendors are implementing, the capability set that we previously had access to is going to be much smaller. So we have to kind of rethink what extensions can do inside the browser. How do you get something like IPFS working on mobile? Like the way IPFS works today, it's a daemon, like it's just a service that's running all the time, and it keeps like 700 TCP connections open. It's a non-starter thinking about a network architecture like that running on a mobile network. It's just not even going to be possible. So we have to rethink about how does IPFS work? And going back to those slides where I was talking about trade-offs, where you have to maybe talk to a centralized service or multiple centralized or federated services to get access to maybe a distributed network of content. These are some of the things that we're looking at today. So Birdie is a private messenger project, and they use IPFS inside their application. One of the things that they did was implement like a proximity, they call it lib proximity, and that wraps everything from Wi-Fi direct to Bluetooth LE to nearby to all of the MDNS features that iOS exposes. And they wrapped that into one library and implemented that so that you can actually say private message somebody in the same room with you using Bluetooth LE. So this is IPFS over Bluetooth. And again, one of the benefits you get from IPFS is that it is transport agnostic because there's no HTTP in that address for data. It doesn't care how you get there. As long as somebody can return those blocks, those bits, in a way that is verifiable because it's a hash of that data, then you could trust it. It's cool. If it came over a hardwire pipe or came by bird or whatever, if you can verify that address against that data, you're going to be all right. Durin is an application that I think as of next month will be available in the iOS and Android stores. And this is really a utility app. Like if you were working with IPFS data on mobile today, it's not like a full-fledged browser or anything. It might be in the future, we're not sure. But right now what it lets you do is share images and stuff from your local photo store that's built into your phone to IPFS using some of the services that these folks are building. It also lets you handle IPFS addresses. So if an app on your phone is using IPFS addresses, it handles that protocol, that intent in the Android parlance, and on protocols and deep links and things like that on iOS, where it will detect that there's IPFS there and be able to load it or save it. It also lets you see things that you've shared before and stuff like that. So it's more of an experiment in what does a technology like IPFS look like when it's actually trying to align with the platform that it's on. What are the features that the OS provides application developers, and how can we use those best in a way that lets end users actually reap some of these benefits? But like things like the network stack of mobile devices is never really going to let us to do the full P2P version of IPFS. So we have to figure out other ways and really rethink the network paradigm that we're using. And we're looking at things like federation and different, talking to multiple IPFS gateways. Seeing which one responds first, various different efforts like that. Agrigor is a mobile and desktop browser that implements all kinds of different protocols, DAD, IPFS, a bunch of different ones. And they're actually looking at how does IPFS integrate into the web platform itself. So if you're familiar with the Fetch API, they basically hijacked the Fetch API and allowed you to be able to do an HTTP post to an IPFS content address. Or an IPNS one, basically meaning that it's mutable, which means you can actually, from within web content, use fetch to post to a local virtual service, which ends up actually posting to the IPFS network. And this is really interesting because it's not just, okay, how do I load to and from the IPFS network in my browser? It's how does this technology actually work into a web developer and web application flow in a way that makes sense and aligns with the paradigms and the idioms of that platform. Really challenging and really interesting. Capilun is a mobile OS that's actually built on Gecko, the Firefox rendering engine. And you may have heard of KaiOS. This was a operating system for smartphones and smart feature phones that was really big in India. It was the #3 mobile operating system at one point. And this is the lead developer there is adding things like IPFS, Filecoin, even NFTs directly into the mobile operating system. And this lets us kind of escape Apple and Google jail and say, what would a native mobile operating system look like that had these types of technologies, Web3 built into it from the ground up? And everything was a web app. So it's an interesting experiment. We're working with them. We have a couple of years that we get to work with them to kind of do experiments, answer some of these questions, figure out what it looks like. We're working with a bunch of, I don't know if you're doing like either media development or open source tooling. We're working with a bunch of different open source projects too. So FFmpeg is basically used in a lot of your televisions actually, because they end up being an open source tool that gets included into and shipped in TVs a lot. And so we're working with them. If you've ever used curl on the command line, this is also a tool that we're working to add IPFS support to. Some of these things work, some of these things don't. We're figuring that out. Ipfs Tiny is a C++ implementation of IPFS that we're using for both embedded devices, IoT, and also development for satellite operating systems. So what does it look like when you have a swarm of satellites that are communicating using content addressing instead of what is typically a proprietary protocol? But there's not a lot of people doing this C++ development, and people are like, well, why don't you do it in JavaScript or Rust or Go or anything else, right? And so getting folks to interested who are familiar with the space and understand the dynamics of embedded programming today and how Rust is great, I love it, but products are going to be shipped with C and C++ embedded code for the next 20, 30 years. So we still need to speak to those developers and give them the tools that they need to be able to ship their products. And finally, space. So we are doing a number of experiments. We announced one with Lockheed Martin last month, and this working with Liberty.space, which is a Greek satellite launching open source project. And we're really it's hard to crack into these spaces. There's a lot of challenges like secrecy and things like Defense Department involvement in basically any country that has a space program. But there's a lot of interest in these patterns. The upside of things like Ali was talking about of things like IPFS when you don't have to think as much about where things are, because you can trust that the data you asked for is actually, that you get what you asked for, is really interesting. And one of the scenarios that actually somebody that we were talking to brought up was, what if I'm a US satellite? Can I trust this configuration update that I got from a Chinese satellite or a Russian satellite or a British satellite? And in the old world, you have to say, well, that sounds crazy, right? But if you trust where you got the address from, you could get it from any satellite going by. You don't care anymore, as long as you trust the source that you got the address from, because you can verify that whoever gave you that data, doesn't matter. It's exactly what you asked for. So there's very unique properties that lend themselves to very sensitive environments, even in interesting ways. There's a bunch of stuff that we figured out we still need to do. Like I said, stuff's new. We're not done. We got a lot of work to do yet. If you're interested, a lot of these are some of the unsolved problems that we're going to be tackling. And that's pretty much all I had to share tonight, but I'm happy to answer questions. Async, I don't know how much time we have left. Thank you.
Alrighty. I think in the interest of time, we're probably going to need to leave questions until the end. If there's one in here that you want to quickly answer.
Nope.
There's none.
Somebody said
Fantastic.
Hamilton.
Fantastic. Yeah, we will grab Matt up now for the final talk. And if you do have any questions, come grab him after we finished. Right.
Well, whilst Liam's getting the, bringing my slide up. Yeah, there we go. Cool. Brilliant, thank you very much. In the great words of Monty Python, and now for something completely different, or not. So we've heard a lot this evening about decentralized file storage and about incentivizing file storage with things like Filecoin. So what I'm about to move to now is something that's actually got a lot of parallels with that. And we're talking about incentivizing and decentralizing AI and machine learning. So good evening, my name is Matt Hamilton. I'm from a company called BitTensor. And I'm going to be talking about the future of AI on the blockchain. But first of all, let's set the scene of where we currently are with AI and some aspects of blockchain. So right now, we're all here participating in a social activity to achieve a goal. We're all here to better understand Web3 and the related topics and technologies around it. So not just from the speakers this evening, but also from the other participants, the talks we had whilst we were eating our wraps just now, and whilst we've been chatting before and after the talks. We registered on Meetup. We've got people here in person. We've got people on the live stream remotely as well. And fundamentally, intelligence emerges from cooperation, communication, collaboration, right? So by doing this social activity, by getting together, by talking about this topic together, collaboratively, we can increase our understanding much faster than if we were doing it on our own, solo. So we could sit and read books and watch YouTube videos. We could, and we will continue to do that. And there's people watching, this live on YouTube at the moment. So, that's all good, and we will continue to do that. But by doing things collaboratively, we can accelerate that intelligence, that understanding, that learning much quicker. So what has that got to do with blockchain? Let's unpack some of the basics about blockchain as well. So blockchain, digital currencies, if you look at what was invented by Bitcoin originally, it was this concept of digital trust and the ability for computers to be able to reach consensus on something. And in the case of Bitcoin, it was about money. It was consensus about balances, about payments, about transactions. And that allows us to build incentive mechanisms for markets that could not really exist before. A decentralized means by which we can incentivize participation and maintenance of the network. And the Bitcoin network is by far the largest aggregation of computing power in the world, and is itself a marketplace for that computing power. So with Bitcoin, you have proof of work. And proof of work in a nutshell involves effectively guessing a random number that fits a particular pattern, right? It's a lottery as to who gets to fill the transactions in the next block on the network. It's what's called mining. And it solves the tiebreaker of the double spend problem when you're trying to ensure that the same amount of cash or the same transaction is not executed twice. So you need to elect a single authority per block, and that authority is responsible for the transactions in the block. So all of the miners around the world, they go about solving this puzzle, and when they solve it, the rewards go to the miner that solved that mined the block, and the rest of all of that effort is basically discarded. It's wasted. So with proof of work, the effort that is gone into, everything that's done there is a means to an end, but in and of itself has no value, right? This hashing mechanism that all of these computers around the world, filling data centers, burning through vast amounts of energy are doing, does not have any value in and of itself. It's a means to an end, right? And that's why, you know, there's other blockchains as well, you know, ones that are more efficient. If you look at payment space, you've got things like the XRP ledger that are much more efficient. You look at things like Ethereum that are moving to proof of stake in order to kind of deal with that sort of thing. But what if there was a way that we could take that mechanism, that incentive, and build a blockchain marketplace where actually all of that work did have value, right? Rather than wasting it, it was actually going towards something useful. What if we could apply that same concept of decentralized, incentivized, permissioned network to machine learning? Well, that's what BitTensor is, right? BitTensor leverages the same innovation that brought us consensus, you know, on things like Bitcoin, but brings it to, you know, what we're deeming the most sort of important thing in this sort of fourth industrial age that we're going through, which is machine intelligence, right? Machine knowledge. The hash function in Bitcoin, as I said, is a very concrete function. It simply finds a pattern or looks to find bytes that match a particular pattern. The consensus mechanism of BitTensor has to deal with a far more fuzzy set of outcomes. It has to deal with, you know, actually evaluating knowledge. So if I ask everybody here in this room to take, say, a paragraph or a page of Shakespeare, for example, and summarize it down to a few sentences, everybody here would come back with probably something slightly different based upon their understanding. Now, the question being, how do we evaluate which is the best summarization of that data? How do we work out which one of those participants should be rewarded and how much they should be rewarded for their effort? And that's what the consensus mechanism in BitTensor does. It looks at it's a decentralized network, and I'm going to go into that in a little bit more specifics. It's a decentralized network with each participant contributing effectively intelligence or knowledge to the network, and they're rewarded in accordance to how well they are providing that information. So in the same way that if I was to reward people here for how well they could summarize that Shakespeare, then hopefully that would incentivize, you know, people to maybe go off and learn more about the Shakespeare to get a better summary and get a better reward, right? So let's just set the parameters of what we're working on at the moment within machine learning. So you could break machine learning down. There's two very dominant types of machine learning. There's supervised learning and unsupervised learning. So supervised learning is the kind of stuff you might have seen before if you've done any machine learning, in which it's categorizing, for example, data based upon that data, a training set of that data being tagged or described. So here's a whole bunch of pictures of dogs. Now go and learn what makes a picture of a dog, right? Here's a whole bunch of pictures of cats. Go away and learn that. And the idea being is that if you give the machine learning algorithm enough data, it will eventually learn what characteristics make a dog, what characteristics make a cat. And you see this in your smartphones when it automatically tags images and says, okay, those are all the images of Matt versus those are all the images of Bob or whatever it might be, right? So that's tagged data. Then the other main thing is unsupervised data, or what is sometimes called, more accurately, self-supervised data. So you give the machine learning algorithm a prompt. So the cat sat on and you ask it, what's the next token that comes back? And it comes back with Matt. Or the quick brown fox jumps over the lazy and it predicts dog. Now, we didn't tell it what the next word is in the sentence. All we've done is given it a whole load of text and said, read through that and try and understand it so that it can come back with a prediction of what the next word is, right? And if you feed it enough data, again, the idea is that it starts to understand sentence structure. What is a verb? What is a noun? You know, full stops, capital letters. And then with more data, things like thematic understanding, you know, understanding what are the concepts, what are the themes that are going on in that text. So in the case of BitTensor, we're just interested in unsupervised. We're looking at that bottom bit, right? We are trying to build models that understand the world around us. And specifically at the moment, we're working within the language domain. So we're working with text at the moment on that side of things. So we're building a massive decentralized neural network that's aimed at, like I said, better understanding the information in the world around us. At the moment, the current state of the industry is that it is dominated by a number of large players. Players like Meta, aka Facebook, our hosts here this evening, Microsoft, Google, Uber. They're all companies that have dedicated AI teams that are working on these big algorithms, what are sometimes referred to as foundational models. And some of them are truly amazing. I'll show you a demo of some of them, talk about them in a sec. But these kind of institutions are doing it in a very siloed way. They're seeking the computational power of say, Bitcoin, but they're doing it in the wrong substrate. They're building huge, great big centralized data centers to process this and to run their models on. But if instead of solving these machine learning problems with big centralized supercomputers, we leveraged every computer available on the internet. That's what Bitcoin showed us, right? You know, the computing power of the Bitcoin network is greater than the top 500 supercomputers combined. So the scale that we could possibly reach for that sort of thing would mean we'd have a lot more availability to train much larger data sets. So let's take a couple of examples from OpenAI. You might have seen people, especially say on Twitter, posting images from something called DALL-E. So DALL-E is a machine learning model it's an image generation model. You can give it a description and it will produce an image. So if you say, I want a picture of an astronaut riding a horse on the moon, it will give you an image, right? It's quite mind-blowing what it can come back with. You can describe all sorts of things and it will come back with them, right? Codex on the right is used by a product called GitHub Copilot. I don't know how many people have seen Copilot, but Copilot is a tool that uses AI to understand code. So as you are writing code, it can be pre-filling things in. So you might write a description or a comment, and it will give you the method signature. You might be able to start writing the body of the text and of the function, and it will start helping you and filling stuff in. But what's amazing is it can actually understand the semantics of the code as well. So you can say, I've written this in Python, please translate it to JavaScript. And because it actually understands the concepts behind the code, it's able to do that sort of thing. So it's able to understand, like, one language might have a construct, a while loop construct, whereas another language might not have that as a high-level construct. And it might be like a for loop and then an if statement with a break in it, for example. And it can start to understand these higher-level concepts and do them as well, which is pretty cool. So but the problem is, OpenAI, those examples I gave, OpenAI is a for-profit entity whose major investor and commercial partner is Microsoft. The models they're building are so large that they can't easily be distributed or run easily. The amount of computing power you would need to run these is well beyond what you'd have at home. So they're only accessible via permissioned gateway and an API. You have to apply for an account and an API key and use them in accordance with a usage policy that they make you see. So not very open. The cost to perform a single training model on something like GPT-3, which is a very advanced text transformer model that's actually used in DALL-E for the language processing, is reportedly $12 million for a single training run. So as a researcher, you're not going to make a few tweaks and kick off the CI and get a build coming out the other end, right? Or you might do. Might get a very big bill turn up. So it's taking many months and many millions of dollars to train these algorithms. So as a result, models like GPT-3 They're owned by OpenAI, and they kind of keep them very close to their chest for that reason. They've invested a lot in them, and they allow access just via an API. So it's a permission system. If you want to contribute to the model itself, unless you are part of OpenAI, you can't really do that. But the speed and increase of computational power has far exceeded that of the increase in developers and researchers. So computational power is going up, so following Moore's law just about, and the complexity of these machine learning models is also going up, sort of exponentially. But the number of people involved, the researchers and developers, is not going up at nearly the same rate. So what we need to do is scale not just the technology side, we also need to be able to scale the human side of machine learning research. And that's what BitTensor is solving for. Not just the technology scaling, but the scaling of the research and development, as it's a decentralized network that anyone has an equal chance to contribute to. So you're not just relying upon a set of employees at one of these large institutions or a set of researchers, but somebody sat in their bedroom on the other side of the world is also able to contribute. And they're financially rewarded for their contribution as well. That's what things like Bitcoin, Ethereum, the XRP ledger, gave us in terms of financial networks. What if we could do the same thing with machine learning as well? So currently we've used this incentive to scale a network up to about 300 billion parameters, which if anyone's involved in AI, it's a pretty large size there, and across about 3,500 nodes and growing. So like I said, currently a lot of machine learning is done in these sort of siloed models. So the model that OpenAI is generating is different to the model that Google is working on, different to the model that Microsoft is working on. And so some of the research is shared in papers and what have you, but the actual training and development of these models is not done. So to train these models, you need to feed them vast amounts of data. And that's not something that they're necessarily sort of sharing in the process of developing. So how can we make that more collaborative? Well, the idea is by using an incentive and the fact that anybody can join the network and participate, we can actually make it more scalable. So rather than what happens typically within sort of academic research in which it's sort of winner takes all and there's a prestige and prize of getting your research done, we're going to make it a lot more equitable and anybody can contribute to the network. So what if you could take a model like GPT-3, which again is a text natural processing model, and instead of training it from scratch, so starting with nothing and feeding it the entire internet's worth of data to learn from, you can actually build it from the previous version, say GPT-2. Or what if you take that on to the next version of GPT or the next language model? And so we can build these collaboratively based upon other models on the network. And in that way, information and kind of intelligence effectively compounds. We're learning, acting collaboratively, just very much as we're doing here in this room today, learning from each other. So we're building this big decentralized network, and it's incentivized like Bitcoin. It's peer-to-peer, anybody can contribute to. And you might have, say, two different machine learning models in different institutions or different companies. So you might have one of them that's being trained to learn how to detect cars, for example. And then you might have another one in another company that's learning to detect buses. Well, if you're doing image processing to detect cars and image processing to detect buses, then there's some commonality there. Both models are going to need to know what wheels are, what roads are. A bus or a car is a particular, size and shape sort of vehicle, right? It's not a cat, it's not a dog. So the idea is that these machine learning models on BitTensor can learn off of each other. So one of them might understand, okay, this is what wheels are. The other one might understand or start to learn, this is what roads are. And they effectively share their knowledge between each other and learn from each other rather than necessarily having to train from scratch. Same way that, if I got everybody in this room and asked you to, instead of just studying Shakespeare, you actually studied different texts and you all came back together and said, well, this is what I learned about this and this is what I learned about this one. And we share it rather than each having to go off and learn from scratch. And not only that, we end up increasing the diversity of the data, which makes these models more robust, right? So even if people are running the same model, they might train it with different training data. And back to our example of dogs, you might only have traded on a certain number of dogs, and somebody in another part of the world has a different breed of dog, and it goes, I've got no idea what that is, right? So, but they might have trained it on that as well. So your model might now know what that dog is because their model has learned it. And that's going to make all of the models more robust and be able to, there's certain number of kind of attacks and vulnerabilities that neural networks are subject to, and this can actually make them a lot more robust as a result of that. And value flows directly to the creators. It's much more democratic. So rather than just employing or going to researchers within these large institutions, anybody can contribute, anybody can be rewarded. And there's a green aspect to this as well, that in sharing the knowledge, you don't have to retrain completely from scratch, right? So you can take an existing model and build up from then. We've heard the phrase standing on the shoulders of giants. And in the case of open source software development, it's a very common thing. We're used to taking libraries other people have built. We're used to, forking something or contributing to it or working with it. And so let's take the same approach. What if we could build neural networks in the same way that we build open source software and all learn from each other? So how does this work in a practical sense with BitTensor? So there's 3 different entities on the network. You've got clients, validators, and miners. So if I start from the right-hand side of the slides there, the miners are the ones that actually run the neural network models locally. They produce the representational knowledge. They're the ones that actually learn from the data and learn how to understand what that data actually represents. They're understanding the sentence structure, the grammar, what is a noun, what is a verb, etc. And they're building that representational, understanding of it. You have validators. So the validators are curating the knowledge. They are the ones that are actually, they send the queries to the miners process them, the miners send their understanding of the, back, and it's the validators that try and establish who has the best understanding of this information. And then it determines, through the consensus mechanism, the validators determine who gets rewarded and how much they get rewarded. So the idea being that the miners that produce the best knowledge and the best understanding get rewarded the most, right? And it uses we've got an internal currency called Tau, and currently BitTensor is a blockchain built on Substrate, which is part of Polkadot, and it's a solo chain at the moment, but one of the things we're working towards is actually joining as what's called a parachain onto the main network, and that will allow the token to flow on and off the network and to things like decentralized exchanges. The tokenomics of the network of Tau actually follows the same as Bitcoin. There's 21 million Tau in total. There's a halving every 4 years, the same kind of model as Bitcoin. So, as a lone researcher, like I said, at the moment, you can't really contribute to some of these state-of-the-art models, right? And there's no incentive really to do so as well. It's very difficult for you to get your changes accepted or published. But with BitTensor, anybody can do, and they can get rewarded for doing that. And the clients, the final one, the clients are the entities that actually are querying the network, right? They're consuming the knowledge. So they're able to pay for that using Tau. So instead of having to go through a permissioned gateway like you have to do with something like DALL-E or GPT-3, you can actually go directly to the network. You can run a node yourself and supply a small amount of Tau or contact an existing running node and go via then. But that's the bit that's kind of bringing Web3 to AI. It's the decentralized, permissionless aspect of it. It means anybody can not only contribute, but anybody can query and use the network. So a little bit of an example here. So this is going to be a screencast of a Python notebook running and querying a machine learning model. So if I just start it there. There we go. So we're importing the BitTensor libraries, and we're syncing what's called the metagraph. We're connecting to our testnet, which is called Nobunaga. And you can see it synchronizes with a network. We then, the next line down below, create a wallet. I've got a test wallet that I'm just using here. We select the network. So this one's 55, which is a model from an entity called Eleuther. And we are, let's go quite fast here. We're sending a sentence. The quick brown fox jumps over the lazy. It sends it to the network, and we get it back. We can run it through the tokenizer to get the results back, and we get the prediction dog, right? So it's understood what that is. So we're then doing another one here. So this is using, just quickly, just restarted that. This is using a thing called synapses. This is why this is on our DevNet. So we're still working on this functionality. And using synapses is a mechanism that allows us to access the network in various different what are called modalities, right? So we can ask it and say, give me one token back or give me a sequence of tokens back, sequence of, what are the next words that are going to be. But it also sets us up for being able to deal with images and video sort of going on into the future. But the second one here, we are passing in the quick brown fox jumps over the lazy, and we're asking it for a sequence to come back. So it goes off to the network, and it's going to come back with a sequence of what's coming up next, right? And it runs it, and we get back, and we get the quick brown fox jumps over the lazy dog and runs away. I don't know what to do, he says, but I can tell you what I think about. I don't know if I want to go to the zoo or not, but I do know that I have a lot of friends that are going to be there for me. So this, like I said, this is running, and then it halfway through sort of seems to deviate into Russian. I probably should have checked to see what that says. Yeah, so what this is, like I said, this is running on a testnet Nobunaga, and the testnet only has a small number of miners on it. So its actual level of intelligence is actually relatively small, but as you can see, it's already started to come up with something that makes sense to a certain point, and especially if your fox is a slightly neurotic, or I'm trying to think of the right word. The fox is, they don't really know what they want to do, really. So anyway, so that's a demo, and that was, like I said, I could actually run that live. I recorded it just for the sake of demo gremlins, but that's an example of querying against the network Nobunaga. So what's coming up? So synapses, that's what I've just sort of demonstrated there, allowing multiple modalities and easier inference on the network. At the moment, you can do inference, that's querying the network. But what you get back is basically a bunch of stuff that's really only readable. You get back what's called a tensor, which is basically an array of numbers, which is really only, you need much more post-processing to make that useful. Synapses will give you what we saw there, the actual tokenized output come back. And it's a common format for all models to use. So we can actually have models that, like I said, process images, process text, video, etc. And then the other thing I've also touched on is parachains. So we're going to be connecting to the main Polkadot chain, hopefully later this year. And that then allows the currency Tau to be traded, access to DEX, etc., etc. There we go. So thank you very much. And if you scan that QR code there, that can take you to links, or you can go to bittensor.com. That'll take you to all the links. There's we've got a Discord channel, take you to our GitHub, etc., and my contact details there as well. Oh, and one final thing before we go to the questions. If anybody afterwards comes up and the first person to kind of tell me who or what is Yuma Rao, I've got a t-shirt to give away. So there's also stickers out there, but there we go.
Thank you, Matt. That was absolutely fantastic. I think we should go to any questions that are in the online chat, if there are any.
Just someone asking, when's the IPO? So you can buy Tau on the it's not available on any public exchanges yet, but you can, if people are interested in buying it on the Discord channel. There's a few people that buy and sell sort of peer-to-peer on there. So, and someone's asking when BitTensor Playground. So a lot of these AI tools have what's called a playground that you can go on and you can type in your query and it comes back with something. We are working on a BitTensor Playground. So we're hoping to get that going. We're getting synapses running first because that's the first precursor to that. And then we'll have a playground going on there as well. But that should allow you to kind of go along and have an interactive play around with it. Or you can, like I said, set up your own infrastructure, set up your own, because it's decentralized, anybody can connect into the network. But the playground will just make it a bit easier for people. Yeah.
Brilliant. I think because of the time, I really want to get this sort of wrapped up here. So we're going to go to a break. So we'll finish here, speak to Matt afterwards. Yep. I want to say a massive thank you to all the speakers that have attended today. I'd love to give them a round of applause. And a massive thank you to everybody who has turned up today to the first London meetup here. Yes, please do come along to the next one. I'm going to be hosting this monthly, probably at the end of every month. The next one's going to be on DevOps. So if you or anybody that you know would like to be a speaker for that one and be involved, please do reach out to us at London Reactor at Microsoft.com. That's wrong. Don't look at that one. Yeah, thank you ever so much for coming. And I think we'll wrap up. If you want to catch Matt afterwards, please do grab him out there. We've ordered a lot of food. So if there's any like hanging around, grab some, please.